Hello today, we are going to learn 2D graphics in graphics. In Module 2 we have these topics: basic 2D drawing operations, transformations, translation, rotation, scaling, clipping, and windowing, rasterization and anti-aliasing, color models, and color spaces. Basic 2D drawing operations are used to create and manipulate 2D graphical shapes and objects. Here are some of the most common 2D drawing operations. 1. Drawing primitives. Drawing primitives are basic shapes that can be used to create more complex shapes and objects. Common drawing primitives. Primitives include points, lines, rectangles, circles, and polygons. 2. Line drawing. A line can be drawn between 2 points using the coordinates of those points. In many programming languages, a line is drawn using a function or method that takes in the starting and ending points as arguments. 3. Rectangle drawing. A rectangle is a 4-sided shape with 2 pairs of parallel sides. To draw a rectangle, the programmer specifies the position and size of the rectangle using its x and y coordinates as well as its width and height. 4. Circle drawing. A circle is a symmetrical, round shape defined by its center point and radius. To draw a circle, the programmer specifies the position of its center point and its radius. 5. Color filling. Color filling involves filling the interior of a shape or object with a specific color. This can be done using a fill function or method, which takes in the shape or object to be filled and the desired color. Transformations are used to modify the position, size, and orientation of graphical objects. Here are some of the most common transformations used in 2D graphics programming. 1. Translation. Translation involves moving an object from one position to another by changing its x and y coordinates. This can be done using a translation matrix, which specifies the amount of movement in the x and y directions. Translation is useful for creating animations and moving objects around the screen. 2. Rotation. Rotation involves rotating an object around a specific point or axis. This can be done using a rotation matrix, which specifies the angle of rotation and the center of rotation. Rotation is useful for creating animations and changing the orientation of objects. 3. Scaling. Scaling involves changing the size of an object by multiplying its x and y coordinates by a scaling factor. Scaling can be done uniformly, which preserves the aspect ratio of the object, or non-uniformly, which changes the aspect ratio. Scaling is useful for creating animations and changing the size of objects. These transformations can be combined to create more complex transformations. For example, a scaling transformation can be followed by a rotation transformation to create a rotated and scaled object. Similarly, a translation transformation can be combined with a scaling transformation to move and resize an object at the same time. By using these basic transformations, programmers can create complex and dynamic 2D graphics. Clipping and windowing are techniques used in computer graphics to control what part of a scene is displayed on the screen. 1. Clipping. Clipping is the process of removing parts of a scene that are outside the viewable area of the screen. This is done to improve performance and reduce the amount of data that needs to be processed and rendered. Clipping can be done using algorithms such as Cohen-Sutherland or Liang-Barsky. 2. Windowing. Windowing is the process of defining a portion of the screen, called the viewport or window, where the graphics will be displayed. This is useful for creating multiple views of a scene or displaying different parts of a scene at different times. Windowing can be done by setting the coordinates of the viewport in relation to the coordinates of the screen together. Clipping and windowing enable programmers to control what part of a scene is displayed on the screen and how it is displayed. This can be useful for creating complex graphics and animations, as well as optimizing performance by reducing the amount of data that needs to be processed and rendered. Rasterization is the process of converting vector graphics, which are described using mathematical equations, into a raster image, which is a grid of pixels. This is done by determining which pixels in the grid are covered by the vector graphics and assigning a color to each pixel. Rasterization is used in many graphics applications, including computer games, image editing software, and web design tools. Anti-aliasing is a technique used to smooth out jagged edges and reduce aliasing artifacts that can occur during rasterization. Aliasing artifacts occur when high-frequency details are represented using a low-resolution grid, resulting in stair-stepping effects along edges. Anti-aliasing works by blending the colors of neighboring pixels to create a smoother transition between areas of different colors. This can be done using various algorithms, such as supersampling, multisampling, and post-processing. Supersampling involves rendering the scene at a higher resolution, and then downsampling it to the desired resolution, which can reduce the visibility of jagged edges. Multisampling involves taking multiple samples of each pixel and averaging the results to create a smoother image. Post-processing involves applying a filter to the final image to smooth out jagged edges and reduce aliasing artifacts together. Rasterization and anti-aliasing enable programmers to create high-quality, smooth, and detailed raster images from vector graphics. These techniques are essential for creating realistic and visually appealing graphics in a wide range of applications, from games and movies to web design and scientific visualization. Color models and color spaces are used in computer graphics to represent and manipulate colors. A color model is a mathematical model that describes the way colors are represented as values. The most common color models used in computer graphics are RGB red, green, blue, and CMYK cyan. Magenta, yellow, black. RGB is an additive color model, where colors are created by adding different amounts of red, green, and blue light. CMYK is a subtractive color model, where colors are created by subtracting different amounts of cyan, magenta, yellow, and black ink. A color space is a specific implementation of a color model. It defines the range of colors that can be represented using a particular color model, and specifies how those colors are encoded as numerical values. Common color spaces used in computer graphics include ZIRG, Adobe RGB, and ProPhoto. ZIRG is a standard color space used for most digital media, including computer screens and the internet. It has a relatively narrow color gamut, meaning it can only represent a limited range of colors. Adobe RGB and ProPhoto RGB have wider color gamuts and are used for professional photography and printing. Color spaces also include information about white point and gamma correction. White point refers to the color of white in the color space, and gamma correction is used to compensate for nonlinear. It is in the way that displays and printers handle brightness. Understanding color models and color spaces is important in computer graphics to ensure that colors are accurately represented and displayed. Choosing the appropriate color space for a given application can help ensure that colors are reproduced correctly and consistently across different devices and media. Thank you for watching. You stay tuned for next part.